All right, guys, we're going to go on and get started with the note sheet today. Now, this first slide's not in your notes, but if we want to find a number when multiplied by itself gives you a negative number. Well, we can use 1, because if we said 1 times 1, we get 1. So positive 1 times positive 1 gives us positive 1. So that's not what we want for this here. Well, we could do negative 1 times negative 1, which is positive 1. And those are really the only two ways we can multiply a number by itself. And in neither case, we get a negative number. Now, I'm going to imagine a number, we'll call it I. When we multiply it by itself, when we square it, we get negative 1, because really that's what we're looking for, is this negative. So, kind of in that notion, if we take the square root of it, we're saying that I, in this case, is the square root of negative 1. And that actually is the case. I is the square root of negative 1. Yes. So by definition, I is the square root of negative 1. And we need this to be able to solve some of the quadratics that were no real solutions. And they actually end up having I as part of their answer. Because when we were looking at the square root of negative 5/2, what we end up getting is the square root of 10 over 2 I is the actual answer. So it would have been plus or minus square root of 5 or square root of 10 over 2 I is what we'd end up getting. So that's where these non-real solutions come in, because I is an imaginary number. So I is an imaginary number. Let's focus in here. That's why we don't have any real solutions for those, because I is imaginary. It's a complex number. Now, the first thing we're going to do is simplify the following expressions. So the square root of negative 25, we can try these in the calculator. Domain error, because the 30xs cannot take the square root of a negative number. But we can break this up and simplify it a little bit. Because the square root of negative 25 is the same as the square root of negative 1 times 25. According to our properties of radicals, now the square root of negative 1 we said is I. Because the square root of negative 1 by definition is I. It's our imaginary number. What's the square root of 25? So the square root of negative 25 is 5i. So really all this is saying is that the negative is going to come out as I, and then we just need to simplify the radical. So if we look at the square root of negative 72, well, we know the negative is going to come out as I. Now what that leaves us with is the square root of 72, yes? Well, I can take the 30xs and say second square root 72, and we get 6 square root of 2. So this will tell us that we have 6i square root of 2. Because the 6 came out of the radical, I also came out. And then we have the square root of 2. Questions on this here? Are we ready for the next one? Negative 5 square root of negative 9. I'm going to try plugging in the other calculator.
Wait, what did you do? What? Use the graphic calculator. Oh, just graphic.
You're welcome.
Right? Really? Yes. Was it your left or your right nostril?
So we got this here. So -5 square root of -9 is indeed negative 15i. Now the graphing calculator does need to be in A plus BI mode. So up at the top between auto and degrees, it says A plus BI. If it says real, to fix that or change that, we have to hit mode and scroll down to where it says real, move over to A plus BI and hit enter. Yeah, y'all can grab a graphing calculator. I would have one of each. Now, yes, you'll need one of these. So, if we did this by hand, the -9 would simplify to 3i, and -5 times 3i is negative 15i, just like the calculator told us.
How do you get the I again? No.
So let's look at the square root of -4. So we can try plugging this in the calculator. Huh?
Sorry, what did you say?
What did I press? Did I press a different number than I was supposed to?
So here it says real instead of A plus BI. Mode, and if you, because if A plus BI is not selected, it's going to say that it's has an error. I forgot the top A plus BI doesn't show up on the graphing calculators. Second,
Wait, real and
A plus BI.
oh,
Because A plus BI is how we write a complex number.
but it's not. It just says doing that. It's not having the end.
Oh, I got it.
Yep, no, it's second quit.
Oh,
Mode. Right next to it.
Oh.
Now do it again.
To do.
So square root of -4. We got 2i, yes? So mode, and then you're going to scroll down. I think A plus BI, or real, has a block around it. Go down to A plus BI, hit enter. So the second one, square root of -12.
I got it. Yeah, I got that.
Is 12 a perfect square? No. The last two we did, 4, is it a perfect square? Is 9 a perfect square? Yeah. So it came out nice. The graphing calculator is always going to give us the decimal approximation of radicals, not the one we want. So here, we do know the negative is going to come out as I, leaving us with what? The square root of 12. In that case, I'm going to grab the other calculator, our 30XS, and take the square root of 12, which is 2 square root of 3. So it tells us that this is 2i square roots of 3. So if it's not a perfect square, we got to take the negative out as I, because the 30xs will not take the square root of a negative number, and let it do the rest for us. Now we can do the next one, negative square root of negative 36. You're welcome. So we'll still have the negative. The negative for inside the radical will come out as I, and the square root of 36 is, so it's negative 6I. 2. Now the square root of negative 54, well, the square root of 54 is not a perfect square, so we will have I. And if we take the square root of 54, we get 3 square root of 6. Now we do need to multiply these together. 2 times 3i is square roots of powers of I. So are you good with simplifying radicals? Powers of I. And what this means, we're talking about I to a exponent. Now I to the first is really I square root of negative 1. Now if we square it, if I said I squared, really we're saying that we're taking the square root of negative 1 squared. And what is the square root of negative 1 squared? Negative 1, because the square root and square would cancel. So what we're saying is I squared is negative 1. Okay. We're going to keep going. We're going to say I cubed. Really, we just took the previous one, I squared, and multiplied it by I. Because we got 3 of them, I squared times I would be I cubed. Now the reason I do this is because we know the value of I squared. I squared is negative 1. And we're going to multiply it by I, but actually just gives us negative I. So I to the third is the same as negative I. So that'd be, yeah, the negative square root of negative 1. I to the fourth. Well, we could say that this is I cubed times I. Well, I cubed is negative I. And if we multiply negative I by I, we would get negative I squared. But what is I squared? Negative 1. So we have negative negative 1, which is 1. So we're saying I to the fourth is 1. We can, yeah. You can. I to the fifth. Well, that'd be I to the fourth times. Well, what is I to the fourth? I to the fourth is yeah, because we got focus a bit, but I to the fourth was just 1. So we're saying 1 times I, which is so I to the fifth is I. Well, I to the sixth would be our I to the fifth times I. Well, on the last one, I to the fifth, we found out it's just I. And I times I is, which is,
Negative 1. Negative 1, I, negative I. It's backwards. Oh, I wrote J over. I didn't realize it was backwards. For real?
so I to the 6th, we got negative 1. I to the 7th, well, I to the 6th is times I is negative I. Anybody have a guess at what I to the 8th is going to be?
What?
Mm-hmm.
I always saw my random stuff was actually right.
Because I to the 5th is indeed I. I to the 6th was the same as I squared, which is negative 1. I to the 7th, we got negative I, which is the same as our I to the 3rd. And I to the 8th is 1, because we would say that it's I to the 7th times I. Well, the I to the 7th is negative I. Negative I times I is negative I squared, which would just be negative 1 times, or negative negative 1, which is just 1. What would I to the 9th be? Yeah, I to the 10th. I to the 11th would be negative I, and I to the 12th, 1. They go in this set pattern. That's why we did this, is I wanted you to see the pattern.
Like, oh my gosh, we're gonna be at this forever.
Because there is this set pattern to it, and I find us actually doing this multiplication out as tedious as this is, we're able to see the pattern, and it makes more sense than me just telling you. Now, there are indeed 4 values. I, negative 1, negative I, and 1 for any power of I. So I to the n. What we do to solve this is we take whatever the power is and divide it by 4, because there's only 4 choices that it can be. And anytime we have an exponent attached to I, we have to reduce it. We cannot leave it. And if we divide the exponent by 4 and get 0.25, it's going to reduce to I. If the exponent is divided by 4 gives us 0.50, it's negative 1. If the decimal is 0.75, it's negative I. And if it's 0.00, it is 1. Now, most likely when you divide in the calculator and get 0.00, it's not going to actually show you a decimal unless it actually is set up to do 2 decimal places. But we get this here. So well, that's essentially what that's saying. Let's look at the first one. I to the 27th. Well, we would take 27 and divide it by. So do 27 divided by 4. Either one works. So we have 6.75, yes? We're not focused on the 6, we're focused on the 0.75. Mm-hmm. Yes. It would not. Because negative I technically is negative square root of negative 1. Because negative I is negative. Yeah. Yeah, negative square root of negative 1. And we don't leave negative or the square root of -1 as part of the answer, we just say it's I, because it is an imaginary number. It does not exist. Now, for this here, this is indeed negative I. Questions on this here? Let's look at the next one. I to the 34th. Well, we can do 34 divided by 4, which is, so we're not focused on the 8, just the 0.5, -1. Because all the 8 is telling me is that I went through those 4 numbers, 4 possibilities 8 times, and then we went 2 more to get to -1. Because each time we went through the cycle once, because at 4, well, 4 over 4 is 1, so 1.00, we went through it once. When we did 8, 8 divided by 4 is 2, we went through it twice. Let's look at the next one, I to the 47th. Well, 47 divided by 4 is, which is negative I. Yes?
Wait, so how do you know the I part?
Hmm?
So it's just one off the.
Yeah, the decimal. Yeah, because when we divide by 4, we're going to get one of 4 decimals, either 0.25, 0.50, 0.75, or 0.00.
Well, with the 0.5, how did you know it was just -1?
Because if it comes out as 0.25, it's going to be I. If it's 0.50 as the decimal, it's -1. If it's 0.75, it's negative I, and 0.00 is 1. So it also tells us that I to the 47th is negative I.
What's that last one?
0, 0. Now 65. So we're not focused on the 16, we just want the decimal. I. I to the, what was it, 64th?
Yeah.
65th is I. I to the 1040 is, it's 1. Because 1040 divided by 4 is what? So the decimal point for this is, so this is 1. Mm-hmm. Now the calculator, when we plugged it in, gave us this. Now e to the -12 in the calculator is saying that we're multiplying 4 by 10 to the -12th. And with -10 to the -12th, what that's telling us, 1 plus, is that we have to move the decimal 12 places to the left, really. So we would get 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is what the calculator is telling us, is that I to the 1040th is 1 plus this here. Now when it calculates I to the 1040th, it's really using a graphing method to find it. And this here we get for our I is a pixel error, or kind of a pixel approximation. And for all cases and purposes, that part is 0. Now, up to a certain point, finding powers of I in the graphing calculator works fine. But once we pass a certain point, we have to start actually interpreting this here, that this is 0. Because if we went one more, I to the 1041, well, if 1040 was I, or 1040 was 1, 1041 should be I, yes? If we hit enter, now we get that times 10 to the negative 12th applied to the first term, which means it's 0, and we just have I. So if it's a small enough power, we can plug it into the calculator. But with 1040, it's easier just to divide it by 4 and pick out the answer. So there are some things the graphing calculator can do. It just doesn't make it easier. All right. Sum and difference of complex numbers. To add or subtract two complex numbers, add or subtract their real parts and their imaginary parts separately, and put them in the form of A plus BI. We're ready for this. Eight minus I plus 5 plus 4I. Since we're adding, the signs are not going to change for the second part, so we can put this here. So we'll add the real parts together first. 8 plus 5. The imaginary parts, negative I plus 4I. That's it. Yep. And in the most parts, we can treat I almost like a variable, but it does have a value. What, I? Well, we can't really add it because we're saying 13 plus 3 square roots of negative 1. They're not like terms, so we can't combine them. That is the final answer, yeah. So a lot of the ways we would treat it as, say, x minus, or 8 minus x plus 5 plus 4x, we treat it the same, but I, unlike x, does have a specific value. Does that make sense? Most variables don't. We have to assign it a value, because when we solve for x, we're solving for a specific value based off the equation. There's very few that have a set value. E is our one, or pi have values. They've been assigned.
On the test picture, it had a lot of sine,
Cosine.
Sine, cosine, tangent.
That's what we did at
Geometry.
I think they have like, I don't want to say this as much, but I think it's like that data stuff. You know this?
Yes.
With the thing in the one.
Let's finish this up. So here, now because we're subtracting, we do have to apply that negative to both because we're subtracting it, which is going to give us minus 3 and plus 6i. Well, our 7 minus 3 is negative 6i plus 6i. Well, that's 0, so our answer is 4. Thirteen minus 2 plus 7i plus 5i. Bless you. Yeah. Graphing calculator. Because second decimal gives us I. It is. You just have to check it out. Decimal. So 2 plus 9i plus 11 minus I. So parentheses 2 plus 9 second I plus 11 minus I is okay. Number 4. Questions with addition or subtraction? Yep. So we'll look at multiplication here. If we did this by hand, we would distribute 4i times negative 6 would be negative 24i. 4i times I would be plus 4i squared. Now I squared is negative 1. So what we have here is negative 24i plus 4 times negative 1. Well, 4 times negative 1 would be negative 4. And we still have our minus 24i. Because the negative 24i and 4 are not like terms.
What was that?
Did you not hear snack pop?
No, it was
oh my
next.
god.
I was like, what is that?
No.
Oh, that was you.
And that's it. Question on this here. Now we could do the same thing with 15i times negative 1 plus 2i. 15i, parentheses, negative 1 plus 2i is 30 minus 15i. Yeah, negative 30 minus 15i. Are you ready? 4i, because it was negative 6 plus All right, let's look at the next one. 9 minus 2i times negative 4 plus 7i. So if we did this by hand, we would distribute the 9 first. 9 times negative 4 would be negative 36. 9 times 7i would be plus 63i. Negative 2i times negative 4 would be plus 8i. And negative 2 times 7i would be negative 14i squared. Now we can combine these two like terms, which gives us positive 71i. Now we do need to simplify I squared, because I squared is negative 1. Now we would have negative 14 times negative 1. I'm getting ahead of myself. Guess I wrote 21 instead of 14, because negative 14 times negative 1 would be positive 14. And there's a reason I wrote 22. Negative 36 plus 14 is. Yeah. Yeah. There's sometimes I get a step ahead and I write the next number, actually do the calculations ahead of time. Yeah. 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 I realized this morning it was getting colder, and it was set that it was auto, so it will keep it between two numbers, and it was keeping it between 72 degrees and 50. I was like, that's not going to work. But we could also plug these in the calculator and get the answer. Questions on any of this here? Get ready for the next one.
Homework. I always know that it's homework next because let's say what time says are we ready for the next one? I feel like
It's not fun.
oh.